Hello student, let's try to understand topic refraction by spherical lenses. You might have seen watchmakers using a small magnifying glass to see tiny parts. Have you ever touched the surface of magnifying glass with your hand? It is plain surface or curved. It is thicker in the middle or at the edge. The glass used in spectacles and that of the watchmakers are example of lens. What is lens? How does it bend light rays? What shall discuss this in the sections. A transparent material bound by two surfaces of which one or both surfaces are spherical forms of lens. This means that lens is bound by at least one spherical surface. In such lenses, the other surface would be plane. A lens may have two spherical surfaces bulging outward. Such a lens is called the double convex lens. It is simply called a convex lens. It is thicker at the middle edge compared to the edge. Convex lens converge light rays as shown. Hence, convex lenses are also called converging lens. Similarly, double concave lens is bound by the two spherical surface curved inward. It is thinner at the edge than the middle. Such lens diverge light rays shown. Such lenses are also called diverging lens. A double concave lens simply called concave lens. A lens, either a convex lens or a concave lens, has two spherical surfaces. Each of these surfaces form a part of a sphere. The center of these spheres are also called center of curvature of the lens. The center of curvature of the lens is usually represented by C. Since there are two center of curvature, we may represent from C1, C2 an imaginary straight line passing through the two centers of curvature of lens is called the principal axis. The central point of the lens is see the center of curvature of lens usually represented by C. Since there are two center of curvature, we may represent C1, C2. An imaginary line is straight line passing through the two center of curvature of lens is called principal axis. The central point of lens is its optical center. It is usually represented by letter O. A ray of light passing through the optical center of the lens passes without reflecting, suffering any deviation. The effective diameter of the circular outline of a spherical lens is called aperture. We shall confine our discussion in this chapter to such lens whose aperture is much less than its radius of curvature and the two center of curvature are equidistant from the optical center O. Such lenses are called thin lens with a small aperture. What happens when a parallel ray of light are incident on lens? Let us do an activity to understand this. The up the paper began to burn, producing smoke. It may even catch fire after a while. Why does this happen? The light from the sun constitutes a parallel ray rays. These rays were converged by the lens at a sharp bright spot formed on paper. In fact, the bright spot you got on the paper is real image of the sun. The concentration of sunlight at the point generated heat caused the paper to burn. Now we shall consider ray of light parallel to the principal axis of the lens. What happens when you pass such a ray of light through the lens? This illustrates the convex lens and a concave lens. Observe in figure 10.2a carefully. Several rays of light parallel to the principal axis are falling convex lens. These rays, after refractions from the lens, converging to a point on the principal axis. This point of the principal axis is called principal focus. of the lens. Let us see now the action of the concave lens. Observe 10.12b carefully. Several rays of light parallel to the principal axis are falling on concave lens. This lens after refraction from the lens, the appearing to diverge from the point on the principal axis. This point on the principal axis is called principal focus of the concave lens. If you pass parallel rays from the opposite surface of the lens, you get another principal focus on the opposite side. Letter F, usually used to represent the principal focus. However, lens has two principal foci. They are represented F1, F2. The distance of the principal focus from the optical center of the lens is called focal length. The letter F is used to represent the focal length. How can you find the focal length of convex lens? Recall the activity 10.11. This activity, the distance between the position of the lens and the position of image of the sun, give the approximate focal length.